Hello everyone, welcome to my channel. Today's topic is portfolio theory. Portfolio theory or portfolio management. So in this, what the benefit of diversification? Because if we are making a portfolio for your betterment. So the main outline for this is portfolio risk and return, how to calculate, measurement of movements in security returns, calculation of portfolio risk, efficient portfolio, optimal portfolio, riskless lending and borrowing, and single index model. Portfolio expected return. Portfolio expected return is a one formula is there. That formula only we have to use. That is ERP, expected portfolio return, equal to summation n is number, I is 1. So that is weightage assigned to security and expected return on security. And n is your number of security in the portfolio. Example here it is given. A portfolio consists of 4 securities. Expected return is 12%, 15%, 18% and 20%. The proportion of portfolio value invested in these securities are 0.2, 0.3, 0.3 and 0.2. This is the probability proportion. So you have to calculate. So how to calculate the expected return? ERP equal to whatever my probability multiplied with your expected return. So I got my total expected portfolio return is 16.3%. So if you have a expected return and if you have a 4 security in your portfolio, so you just check the return and whatever the invested that security proportion is there, like, and always that proportion should be equal to 1, like 0.2, 0.3, 0.3 and 0.2. If combined, you will get 1. So it should be always a probability that is equal to 1. So that proportion you should see and you have to multiply. You will get your expected return on the portfolio. Now, what is portfolio risk? The risk of portfolio is measured by the variance or standard deviation, decision tree. Many techniques are there of its return. Although the expected return on a portfolio is the weighted average of expected return on the individual security in a portfolio, and portfolio risk is not a weighted average of the risk of the individual security in the portfolio. So expect when the return from the security are uncorrelated. Measurement of movements in security return. To develop the equation for calculating portfolio risk, we need information on weightage individual security risk and weightage movement between the return of security including in the portfolio. That actually measure how it will measure. It will be measured by the covariance or coefficient of correlation. So covariance means what? Covariance of Ri Rj. 2 is there written. So Pi is equal to Ri1 minus expected return. Then Rj1 expected return plus your P2 Ri2 minus expected return of J. Like it is a continuous if you have a 4 or 5 securities. So Pn Rin minus Erj and Ejn minus Erj. For one example, the return on asset 1 and 2 under the 5 possible state of nature are given below. For example, state of nature probability is given. State of nature like 1, 2, 3, 4, 5. Probability is given again 0.1, 0.3, 0. I told always probability that is equal to your 1. And return on asset will be given. Here it is a negative return, here it is a positive returns. And return on asset 2 is given. So how to calculate expected return? We know we have to multiply with probability into return. If you multiply, you got your expected return for asset 1, and the same thing probability into you have to multiply the return of asset 2. You will get the value of expected return for 2. Now, this is the thing, if you calculated the expected return of both the assets, now you have to find the covariance between the return on asset 1 and asset 2, because I have asset 1 expected return is 16% and expected return for asset 2 is 14%. So how to calculate? See, for covariance, this is a very important question in for MBA students in specialization paper, portfolio management and security analysis SAPM paper. So, or advanced financial management paper. So here state of nature for 5 security it is given, probability is given, our return is given. This is as per the question, nature, probability and asset is given. And here what? Deviation of the return on asset 1 from its mean. So already we know the mean how to calculate, and then we have to calculate the here this value deviation. So deviation, if we calculate and return again for the asset 2, again we have to calculate the deviation. So what is my product? Whatever my probability into I have to multiply with the deviation on the return of asset 1 and into the deviation of the return for asset 2. If I will get the total sum, I will get here covariance. A coefficient of correlation. Coefficient of correlation between the two Ri and Rj. So what is the formula? Rho Ij equal to sigma Ri into Rj. So if I will calculate sigma Ij, sigma I into sigma j, so sigma Ij is equal to sigma Ij, sigma I into sigma j. What is that? This rho is a correlation coefficient between the return on security I and security j, and sigma Ij is a covariance between the return on security I and j. And sigma ij is what? Your sigma is your standard deviation, symbol is sigma. So standard deviation of the return of security I and security j. So portfolio risk to at security case is what? Sigma ip is, this is a formula. What is the formula? Sigma p. This is a standard deviation of portfolio. W1 weightage of 1 square sigma 1 square plus W2 square plus 2 W1 W2 rho 1 to sigma 1 sigma 2 root over. So if I am having weight of 0.6 for first one and 0.4 for second one, and standard deviation is for 10% and 16%. So and rho 1 to value is 0.5. It is given in the example. So we have to put in the formula sigma p equal to all the values given. You are able to solve it. Same thing for portfolio risk for n security case. Same here. One more example is given. Ki weight is given for 3 security. Standard deviation for 3 security. Rho 1, 2 is given. So you have to again use the formula because previous example is for within the 2 securities. Here it is for 3 securities. So 3 security again the formula will remain. 2 security it is same, and for 3 security if you are adding, then you have to change the formula little bit here. For the weight of sigma w1 sigma 1 square w2 sigma 2 w3 sigma 3, then 2 w1 w2 sigma rho 1 2 sigma 1 sigma 2 plus 2 w2, because first you compare with 1 and 2, then 2 and 3, and so that comparison, and then you have to calculate. Then again risk on an asset portfolio. Again sigma p, you have a matrix, because if you have n number of, because we had done in the previous one here for between the risk 2 security case, simple formula w1 square sigma 1 square plus w2 square sigma 2 square 2 w1 w2 rho 1 2 sigma 1 sigma 2 root over. But if you have a n number, then this is the formula summation wij and whatever, and you have to continue it. So that is there. If you have again n number of, so you have to do n into n matrix. So in that you have to use this matrix. This is very beneficial and this is very important information. If you have a 2, if you have a 3, how you have to put key n number of. Key here it is for the 2, here it will be the 3, then here it will be the n number of. Now, dominance of covariance. As a number of security include in a portfolio increases, the importance of the risk of each individual security decreases. See, market suddenly it will be go high and come down. That time you have to manage your portfolio. So you should know which portfolio, how it is performing, and based on that only we are able to do the portfolio analysis. So, as the number of security included in a portfolio increases, the importance of risk of each individual security, definitely it will decrease. If it is in my portfolio, 50 stocks are there, so definitely my risk will be little less, because where the significance of covariance relationship will be increases. If it's in frontier, for the two security case, if we have a two security, security A and security B, and here expected return is 12% and 20%, sigma is given, standard deviation and coefficient of correlation is given. So now what you have to do, we have a portfolio A and here B, 1, 2, 3, 4, and here the question it is given, the proportion of A, WA is given, WB is given, expected return, what, how to calculate for RP, you have to multiply proportion, you will get value. The expected return, if you will calculate here, it is, you are able to calculate, then standard deviation sigma P is given. Okay. So how to draw the graph? Portfolio option and efficient frontier. Because this is the x-axis and y-axis. X-axis is the risk, sigma P, and here expected return. So you have here all the value, expected return and your sigma value. If expected return and sigma value is given On the basis of that, see here, what is my minimum? Minimum is 12% and maximum is 20%. Here in standard deviation, my minimum is 16.27% and maximum is 40%. So based on that, I have to draw a graph. That is, we can say it is a risk return graph, and this we can say it is a efficient frontier. Feasible frontier under various degrees, coefficient of correlation. So in that also expected return and standard deviation is given, and we have to measure and we have to draw. Now efficient frontier for the n security cases, the graph should come like this. Standard deviation is sigma p, expected return is rp. When you will draw the efficient frontier, the graph should be like this in the curve. Optimum portfolio, where the standard deviation is going, where it is going upward, this is going from the sideways, and it is like this. So this is a combination of all these three previous what we had done. Now riskless lending and borrowing opportunity. In that also, thus the opportunity of lending and borrowing, the efficient formant change, it is no longer effect and the dominant effects. So this is again one graph based on the sum in next class I will do. And the again separation theorem. Since RF, this is not there actually for MBA syllabus much. Since that is every investor would well choose some combination of RF and SA conversation investors. Maybe they choose some point like U, and aggressive investors choose point like V. So that's how the it will be separated, how you will identify your risk of the security, risky security, and how you will choose. That is depend on your risk attitude. And this is very important of the separation theorem. And single index model, SLM model. And single index model, it will be information intensity of Markovnikov model, and N security, how the variance will be, the formula is there, n minus 1 by 2 covariance term. And SARPE index is there. SARP index is RIT, AI plus BJ, MT, RMT and EIT. So here it is again expected rate of return if you have to calculate. So the formula is AJ plus BJ, and then here it is what? ERM, and the how to calculate the variance RI and covariance of between the two security. So here this is the formula, and I am now summing up in this key portfolio theory originally proposed by Markovnikov is the first formal attempt to the quantity of the risk of a portfolio and develop a methodology for determining the optimum portfolio. So how to calculate the expected return of the portfolio of n number of securities, ERPW, summation WI ERP. So here EIJ. So the variance, how to calculate standard deviation, because if you have to calculate the any risk, you have to use a technique that is standard deviation. First you have to find the mean, then you have to find from that standard deviation coefficient of variance and covariance. So then standard deviation, how to calculate, and portfolio of efficient if it is, so how you are able to measure. So given the efficient frontier and the risk return indifference curve, the optimum portfolio is found at the tangency between the efficient frontier and utility in difference curve. So we can introduce the opportunity for lending and borrowing at the risk rate, and efficient frontier change accordingly. So single index model also proposed by SARP in the beneficial simplification of the Markovnikov model. So this much is there in this slide. So next slide maybe I will explain about the single index model. Thank you so much.